So welcome everyone. I'm glad to see that so many people came here today. My name is Sander Bos. I'm from the Netherlands. Yeah, well, what can I say? A short introduction maybe, really short. I'm a long-term Unix and free software user, several kinds of Unixes. I also contribute to several free software projects. So I'm a Unix and free software user, but that of course are two things on the same aspect. My main focus points in the computing field are system administration, Unix system administration, and also a high focus on security. Okay, so that is me, but what is this talk about? I hope you all read the talk's description at the SIGINT site, probably, which is why you're here right now. The talk is about how I unintentionally hacked a geek hack conference, nerd conference, whatever you want to call it. It's the SIGINT13 conference, which is later this month in the Netherlands. But from there on, I started a personal journey with some help from a good friend of mine into the world of web security. And I will talk about that. The result of all this was that there were a lot of problems fixed in the several systems for several conferences. And also a talk here at the SIGINT conference. Okay, well, first, a lot of ramblings about copyright and licenses. Why am I doing this? Please take 1 minute of time to read all of this. The talks that the speakers are held are being recorded. If they do not disapprove, the recording is put on a license, so the talk is put on a license as well. So I went to think about it. I read the CC licenses, I read the Creative Commons page. I learned a lot about not only Creative Commons, but copyright and licenses in general. But at the end of the day, of course, I had to choose a license for my talk and for the recording and for the slides. It ended up in several different licenses. As you can see, I'm not going to name everything what's on screen, but please take a short look and maybe something to think about when you're watching all the speakers. They may or may not be aware of what happens with the recordings. And that is a second point, because relicensing of any work is, as I understand it, never allowed by copyright nature, unless by the copyright holder itself. So, for example, someone puts a talk on YouTube. Well, bad luck. YouTube has relicensing terms of service. They pretty much invalidate the whole copyright system. So it's not allowed. Only the copyright holder himself could do it. Okay. So let's get to business. SIGINT uses CFP server, which is the system where proposed speakers can put their talks on and see if they get accepted for the conference. The system is called FRAP. It's a Ruby on Rails application. I heard of Ruby on Rails a lot of times, but I never really digged into it until I used this system. And it wasn't even for SIGINT that I encountered it in the first place, but it was at the OHM conference. So what happened? One night I was logged in and I was trying to edit my call for paper there, and suddenly the server didn't respond. So, okay, panic. How can I log out? I mean, where's my session? Is it lost in cyberspace, or should I wait until the server gets back up again? Or yeah. So it was a little bit of a problem. So I asked a friend of mine for some advice, and I requested some help. And he said, oh, is it a Rails application? Most likely the full session is being kept on your client in a cookie, all the information pertaining to the session. So if you just delete the cookie, then it's fine. Oh, okay, well, that's good. I could go to bed that night. But he also said, well, you know, don't just try deleting the cookie, but first try decoding it. You know, you can have a lot of fun and you can learn something about Ruby. So I said, okay, let's do it. While decoding the cookie, I discovered that there was indeed more information in the cookie than I at first expected, and not just the information am I signed on or not, but some more. And well, while on the topic, the cookie is also signed by the server. It is done with a secret token, so it's well, literally a signature made by the server so that clients cannot impersonate the server. They need a secret token. But, by the way, he said, there's a little problem which is very, very often made. The secret server token gets put in a public source repository at times. Okay, so what does that mean? What's the problem? I will talk about the problem, but first we went to investigate if this indeed was also the case at the OHM conference. And to our surprise, maybe my surprise, not the surprise of my friend, it was indeed the case. There was a secret token on GitHub. Yeah, well, it sounds familiar. I don't know, but so let's try if this is indeed the actual secret token that's being used by the server. You know, there can be a file on GitHub, but that doesn't really prove that it's actually being used on the live server, on the production server. But if it is, well, the risk is you can become any user that you like, because you can create your own session, put any information in there, whatever that you like. So we went to investigate this, and well, it's not always a smart thing to do things on a live server, especially not when it's your own account. But even without that, of course, we set up a local setup and tested it there. So we basically set up a Ruby on Rails server. The FRAP application was installed, and we used the same source repository as the OHM conference, so the same server token also on our local system. Well, everything worked as expected, which means it was completely broken as expected. The secret token was indeed, well, it could be exploited in the way that we thought that it could. And that, of course, was the actual, well, the actual test was doing a proof of concept on the server, on the live server of the conference. And what we tested was creating a cookie, so basically creating our own session and then signing it with that secret token and seeing if the server accepts it. Well, we did a little test, 1 or 2, at the OHM conference, and yes, it worked. Okay, so it's broken. Well, that's bad news. But it's even worse. The issue originated from the upstream FRAP application. So the OHM conference made a fork on GitHub, but the problem already existed at the upstream application. And it's not only OHM, because when you're searching for these things, you will find more conferences that have the same problem. Well, Frostcon, our friends here in Germany, they had it as well. FastCon, I found out a few weeks ago, has it as well. It's a US conference. They all use FRAP, but they all have the same default installation with the same secret token, which is not secret. Yeah, well, SIGINT, also interesting. How did I get to know about this conference? Well, you guess. But they were not vulnerable, so that's the good news. I will elaborate on this specific issue in a bit. While investigating the OHM conference, we found some other problems, well, pretty severe problems, actually. At first, there was a HTTPS to HTTP redirect. So basically, the problem was when you as a client connected to their network, you get to the front-end server, but in their own internal network, they have a back-end server. The last two, they speak HTTP, and the client on the internet and the server on the front end, they speak HTTPS. But while translating translating and redirecting stuff from the internal network to the out network, the HTTP part was basically lost. Another thing was that cookies weren't secure. Well, cookies being secure, what the heck is that? A cookie can have a property, an attribute, which is the secure attribute, and it basically tells this cookie may only be sent over HTTPS and not over HTTP. So the first problem, the redirecting, say I log in, I do HTTPS things, but then I get redirected to a HTTP page. Well, it's a problem. Well, it's a problem if the cookie is not set secure. If it was set secure, then it would not have been sent to the HTTP server in the first place. Well, it was pretty messed up. But I reported it to the conference, and they reacted very quickly. That means the server went down again immediately, and things were fixed, I think, in a half a day or something. So really good response. Yeah. This holds true for OHM and also for Frostcon, and Frostcon as well. So, elaborating from there, well, like I said in the beginning, I wasn't really into Ruby, but I'm not a web developer myself either. I knew about cookies, but not so much as I know now. So, just for your idea, yeah, well, let's explain a few simple things about cookies, web session management, and also the way Ruby on Rails handles this. HTTP, as we all know, is a stateless protocol instead of, for example, TCP/IP. So a server does not know that a client is having a longer conversation. Each request is a request on itself. They do no handshake, for example. So there's basically no such thing as being logged in. You log in each time with each new request, each mail that you read or whatever action that you're doing, and you send the cookie with the request, and the cookie says this user is logged in. But there's no such thing actually as being logged in and then logging out. Well, cookies, you can read about them in the RFC 6265. Basically, it gets set by a server. The client stores it in its cookie store, and with new subsequent requests, it gets sent back to the server again. So how does Ruby on Rails do session management? Basically, there are two ways. It either stores information of the session on the client, or it stores the information on the server. When it's being put on the client, which was the case in the example that I just talked about, it can pose a problem because the server has to trust the clients. If the client can manipulate the cookie, which we did, then the server will accept it, and it will not be able to compare it with a session line in its own database, for example. That is the case, though, when the session is stored on the server-side storage. Yeah, the latter is also much more secure in some ways, but I would really advise, if it's possible, also compared to the load of the server, to use server-side storage and not client-side storage. Okay. Well, some more things that I learned, or at least read about much more than I did before. There are a few problems with cookies, or a few risks that you pose yourself to. One thing is session hijacking. So when a cookie gets sniffed by a person, he can use that cookie. Well, that's quite logical, because he just captured it and used it himself. It poses a problem when there's sensitive information in the cookie itself. But it also poses a problem if it can be used indeed to log in to a server, even if the initial user who initially created it has logged out himself long ago. So you basically hijack one's session, and he doesn't even know it. It also means that you don't need to know credentials, so you don't need to know a name or a password. You just have the cookie, and the cookie says, okay, you're logged in. You're now, well, you name it. I think we all remember Firesheep. Well, Firesheep was a huge success in a way. It really created, well, no, it really showed the problem on a big scale of cookies that were being able to be sniffed. Okay, a second point is session manipulation, which can be done when the session is stored on the client. It's exactly what we have seen. We manipulate a cookie, and even though it was signed, that was useless because the signing token was not secret. Another thing which can be used at server-side storage is session fixation. It's a bit more complicated. Basically, you create a cookie, you leave it on a computer, someone else uses that computer after you, goes to the same page, let's say Hotmail, and you have prepared a session ID in the cookie, which is still on the machine, on the client, and the second user, well, he doesn't know it, but he uses the same cookie to log in. While at first the cookie didn't even mean that someone was logged in the second case, this is the case. So you can also hijack someone's account in this way. Okay, well, the conference hack, I will elaborate on it a bit. Basically, this is the overview of the process that was being done. You log into the server, or at least you contact the server, because you didn't even have to have an account in the first place. You just connect and you get a cookie, and then you can manipulate the cookie already. You export the cookie from your browser store, so that you can manipulate it in this way, which is being done by Ruby, in a Ruby environment. Manipulating it basically means decode it, edit it, recode it, and resign it, which you can do, again, by the not-so-secret token. Then you import the cookie back into your browser, and you connect again to the server, and the cookie will be used, and the server will happily accept it. So, some impacts. What can actually be changed? There were basically 4 parts in the cookie, and 3 are interesting. The first one is the session ID, which is basically, well, an identification for your session. And the second part is your user ID. Well, now it gets interesting, because say you're user 300 and you change it to user 1. That's the admin in the Ruby on Rails application, also in Frap. So, you're admin. Okay, pretty severe. But it can even get worse. Well, it was pointed out by Jorgensen, if I pronounce it correctly, on the Frap GitHub page. Basically, after the issue was fixed by the Frap developers, this guy sent a message and he said, well, this is severe, send out an SA, because remote command execution is possible. Well, that was new for me, and I haven't tested it locally. But you can get a shell by means of using a cookie and having the secret token, and then generating your cookie yourself. This was actually the work of Charlie Somerville, but Jochen elaborated on it, and you can find blogs for both people to read more about it. Yeah, the demonstration, well, that's the tricky part now. It's not going to work in full, but I will try my best. Testing. Yep. Okay, so we have here, what we have here is a Ruby script, and well, basically the first step is indeed you log into the application, you get sent a cookie, then you export the cookie from your browser, so basically you just copy the string, and we can see that right here. The cookie's content is oh, is it readable? No. Yeah. One of the things that got lost by restarting X some minutes ago. Is it now readable? Yeah, in the back? Raise your hand if not. Oh, that sucks. Sorry? Switch the lights? Yeah. Just press them all. I can try. Yeah? Or this? No. Okay. Okay. We copied the cookie from the browser, which I unfortunately am not going to show right now because it's too much hassle to open the screens again, etc. But it consists of 2 parts. This is an encoded part. And the second part is the signature. Again, the secret token is used to create the signature over the cookie's content, the cookie's value. Then we invoke some Ruby magic, and again, I'm not a Ruby developer, I'm not an expert at this, I got much help on this part, but basically when you see it, it's just a few lines, an easy script, and anyone can use it, whether or not he actually understands what it says. So the first thing that we do is we decode the cookie, which consists of 2 parts. It's both base 64 encoded, And on top of that, it's marshaled. It's a Ruby method to encode a cookie. I will put the script into Ruby in a minute, so we can see the output of it. Then the second part is the interesting part. The impact that we choose here is changing the user ID. Remember, this is a cookie which has been generated after logging in, so a user ID field is already present. We're just changing the value. But you could also connect and not log in to a server and then add this value. Basically, you can do anything. But this is an easy way. Then we're going to show the new cookie. After that, we re-encode the cookie, we recode the cookie. So we do the reverse of what was done before, base 64 and then Marshall. No, sorry, the other way around. First Marshall and then base 64. And now the part in which the SIGINT token is involved. We recalculate the signature using that not-so-secret token. I'm not going to explain this whole line, but this is the way that Ruby can use sign cookies, or can sign any content basically. And so the result is a regenerated signed cookie. When we indeed add the signature here after the cookie. Okay. So let's invoke the Ruby clients and give him this file. Yes. Well, this is not colored, unfortunately, but well, it speaks for itself, basically. We got here the decoded cookie, the original one, consisting of a session ID, a CSRF token, which I'm not going to explain now either, and then indeed the user ID field. Well, in this case, it was user ID 2. It was just the first extra user that I created on the local system, not running right now. Then we change this user ID to 1, so we become admin. So we show the new cookie, and you can see the change here at the end. User ID has changed from 2 to 1. We recode it, a lot of garbage here, recalculate the signature, and then put the two together. Now, next up, there are several ways to inject a cookie in a browser, but the method that I used and which I wanted to show you was this one. Just use the SQLite clients to insert the cookie in the database of Firefox, the SQLite database. We can also see a few more values here. Well, this is the name of the database. It's the first record. Local domain is the domain, in this case, on which the cookie is valid. Frap session was the name of the cookie. Then we have here this whole string. It's the value up until this point. The next field is the username of the host that sent out the cookie, the host for which the cookie is valid. And after that, we have some other values, which are expiry time, a last exit, and those kind of things. I can, however, show you a few screenshots of what happened a few months ago. So what I wanted to show you was indeed first logging in, then changing the cookie, and then requesting the user edit page again, and then we would see that the email address which was shown was actually the email address of the admin user. But let's look at some screenshots of the production service from a few months ago. Well, this is the Frostcon one. Just to URL above. One thing I didn't explain yet was that the cookies can also hold a flash message. And it's basically a message that is being shown on screen. For example, if a user has logged in, then it says successfully logged in, or when it has not successfully logged in, it says invalid password or invalid username, which is this one indeed. But of course, if you can alter the cookie, you can also add new lines, new flash messages. In this case, I thought it was funny to choose pound. People like to use it. So this is for Frostcon. The original server which was found to be vulnerable is the OGM one. It's basically well, the same proof of concept. But we can also combine the two in a way that a cookie that was originally sent out by one conference can be injected back into the other one's system. Well, that things can get interested in, because if you are user 13 on a system and you would just like to see who's user 13 on another system, go ahead. If they use the same secret token, if they use the same signature, then the cookie will be valid on either of the systems. Yeah. Okay, so enough of that now. Some things that we may learn, hopefully. I have some general advices, which may not be new on itself, but given the fact that, for example, the not-so-secret token issue isn't new at all. In fact, I spoke to a guy who found about 5,000 projects who had the same problem. He just searched a query in GitHub for secret token.rb, and you get the results. They may have even closed that search function right now, I'm not even sure. But if you secure things from the start, then you might prevent a lot of problems. So not just being things like secrets that are being put in public source repositories, but also start off with the source code on itself. For example, when digging in the FRAP application, I may be wrong. If someone thinks knows I'm wrong, then please correct me. But I think it stores the passwords of users in a clear text way in its database. Another problem was that session fixation. Indeed, I found it to be it could be done within the FRAP application, so that's also a bad thing. I'm not saying that the FRAP developers are doing a worse job themselves. They say, well, it's still in production. We haven't even had a release. So okay, fair enough. But please consider the fact that people are actually using this in production in real life. SIGINT itself as well, but also on the other side of the ocean. Well, we have use of SSL, of course, and correct use. I will talk a little bit more about that in a minute. Secure cookies I already talked about. There's also an HTTP header, which servers can send to clients. It's the HTTP strict transport security header. And what it basically says is, once a client has accessed a page on HTTPS, it should not degrade after that to HTTP. So this would prevent, indeed, HTTPS to HTTP downgrade redirects. It's not the right solution for this problem, but it does prevent it, or at least it may prevent it. And also, of course, check site redirects. Well, I explained one thing with the backend and the front-end server, but another issue which pertains at the Frostcon conference is that typo3, which they use as a CMS, has defined a base URL, which is an HTTP URL, and the HTTPS pages which can be reached at the Frostcon conference, they also use that same base URL. So you go to an https frostcon.org page and then you click some further, but sooner or later you will be redirected back to HTTP because of this base URL that is put into the sources of the HTML files. Yeah, well, like I said, of course, a public source repository, yeah, please use it, but be aware of what you actually put in it. I explained the secret token issue, but there were also actual passwords found in one of the repositories. It got fixed, but the point is that it happened in the first place. And well, it seems that not everyone is aware of a public source repository, or maybe not used to it, and thus, it is used to put the configuration in source repositories, but is not being aware that it's actually being public. So that's really something which should be thought about more. Then I'd say if there is a critical fix to a problem, to a program, in this case the FRAP application, please try to tell the users this actively. There was a message after a few days on the FRAP mailing list, which is good, but the FRAP mailing list is probably only read by, I don't know, 10, 15 people. Most of the people also actually developing on the system, or at least using it. But it doesn't reach all users, of course. What I would advise is FRAP, well, consider actually doing the first release now. Release a security advisory with it. Maybe request it CVE, so the whole world knows it. And indeed, well, alert use actively. You can also put clear signs in the release notes if it is a release, but otherwise in the change logs. Then another point, forking. I'm a BSD user, and one of the things that I don't like about BSD is that they basically fork software. They have their own base source repository, and they say, okay, OpenSSL, we import it into our base. OpenSSR, binds, you name it, they import it. But importing basically means forking. And when you fork, you should, of course, make sure that the software gets updated when there is an upstream release, or at least in cases of critical fixes. BSD lags here and there, but this problem also persists in this case, because why were so many conferences vulnerable to this issue? Not because they use FRAP on itself, but there was another problem. Some of them forked the source repository. So I had to contact more parties to get things fixed, which was also a nice thing to do, and I learned a lot. But when you fork, you get the bugs and the vulnerabilities for free. Like I said, this issue also was already available in the upstream sources. What I also saw was that one party fixes it this way and another party fixes it that way, and at some point I stopped following the commits on GitHub because, you know, it's a maze. Well, it's inconsistent, and the projects diverge in ways that they probably didn't intend to diverge, which could also lead to resulting in less security. Frostcon is well, it's quite remarkable. They did fix the live server, but not the GitHub source repository. So guess what happens when they reinstall their server or someone else forks or uses their source repository? The issue would come back again, the secret token issue. Also, they did activate server-side storage in the Rails application, but only on the live server, not on the source repository. So please do that, Frostcon people, please. Concerning forking, well, I'm not sure if many parties on GitHub do it because it's cool and GitHub says, yeah, well, this is why we exist and you can fork and then develop further. But I would urge people to only fork when it's really needed and not for fun. Because we've seen problems when source repositories gets forked and the initial one has a bug. Try to get it fixed. And if you do fork, for whatever reason, and you may have very good reasons to do so, of course, follow upstream's commits. It's upstream's job to make sure that people are aware when critical fixes are fixed, critical vulnerabilities are fixed, but please do follow the commits. So you can integrate, you can pull up changes that are made upstream into your own application. And also if you do fork, it also works the other way around. When you have found a critical problem, which was already present in the upstream source, and also in other forks, send them upstream. I would like to point out two detailed case studies of parties that I contacted, I reported the problems to, which started out with the FRAP issue in itself, but like I previously mentioned, there were other issues found. The first is the FOSCON conference in America. Well, you can read it, free, low cost, you can choose for yourself. Community organized FOSS conference. I think it's comparable to FROSCON. They had the secret token FRAP issue, but they also lacked SSL for the CFP system, which was FRAP, and obviously no secure cookies, because without HTTPS, no use for secure cookies. I reported it, and literally a few hours later, the first two issues were fixed. So the FRAP issue was fixed. They magically used SSL within a few hours, not for the whole site, or maybe for some parts of the site with an incorrect certificate at this moment, but at least the CFP part, in which people sent their credentials and the personal information, it got secured. So that's very good. The third issue, well, when HTTPS was activated, then became the need for secure cookies. I think it did take some longer. Actually, I think it was 2 days ago that I pinged them again, and they finally fixed it. Well, they did actually fix it already, but someone forgot to restart Apache. So the configuration change didn't have effect. That can happen, but well, it's quite sad that it does happen. But all in all, I would like to say it's excellent response and excellent work. So I compliment them on it. But it can also be much worse. If I don't drink now, I will not survive this. It's a HATB Hack in the Box security conference. I think it was 2 months ago in Amsterdam, last edition. It's biannual, so twice a year. Once in Malaysia and the other half in the Netherlands. Looking at the site, it's quite expensive. Looking at the images in the news a few months ago with the expensive hotel, I think Putin stayed there as well at that time. So it seems like a really big conference. Looking at the website, the sponsors are no small names. I think we have Microsoft and Facebook as the first two. So you would expect that things were settled correctly. By the way, they did not use FRAP, which was the reason why I went to look. But it started out with no SSL for CFP, which we also saw with Foscon. They have 2 separate ways for getting into the CFP, the creation and the login, but it's not the same method being used instead of, for example, with the FRAP application. So it's basically a double error. When looking some further on the websites, well, some pages did happen to have SSL, be HTTPS secured, but there was mixed content. I think we all know what problems that can mean. We have also HTTPS to HTTP downgrading, not a good thing either. And, well, also surprisingly, invalid certificates. So SSL is used, but it's basically, well, it's not used correctly. When clicking even more further, I got to the visitor registration pages. Well, guess what? No HTTPS. And as we all know, at some point you have to pay money, in this case. So I'm not sure what the actual payment method is. I didn't look that far. But like I said, both in HTTP and HTTPS, but you can guess which one is being linked to mostly, not everywhere, but mostly on the site. So you access the HTTPS main page, and then you click on register because you want to go there, and then you're redirected back to HTTP. Oh, okay. Yeah, like I said, the payment procedure is unknown, but there is mentioning in the terms of service for visitors about some credit card things being discussed and sent over email. I don't think that's a good thing to do. And all in all, being a bit sarcastic, of course, I thought, is this a joke? Or is this whole site maybe a hoax? I don't know. Is the hope lost? And, well, should we even bother trying to fix this? Because, I don't know, such a big conference, and apparently they don't get the site right. No offense to anyone. Okay, so getting back, getting at the conclusion of this talk. One of the main messages is, well, web security is hard, it's not easy, we all know that, but it can go wrong with the experts, even with the experts. But also old mistakes keep being repeated. Nothing in this talk is actually new to anyone here in itself. But it may be new that even indeed the experts make the same mistakes. We have lack of HSL, we have SSL errors, incorrect certificates. We have the secrets in RCS. We've all seen that before, and I think the FRAP issue isn't solved at all. Because, I'm not sure if I skipped it, but FOSDEM is testing FRAP at the moment, and I don't know what source repository they are using. BSDCan and PGCon, 2 conferences in America and Canada, they contemplate using FRAP as well, so look out for that. Or if you are involved in those conferences, please make sure to not make the secret mistake again. So one of the things that I would try to summarize is that we really need to, I think, do better, and we can do better. So let us do our best to move towards that goal together. Yeah. So I'd like to thank you all for being here. Are there any questions or thoughts or comments? Yep.
So if you've got this token, it's not included in the cookie, it's being used to sign the cookie, and you've got no session handling at all on the server, then having the cookie must allow you to brute force back to the token because there's no secrets in there. You've just, all they must be doing is like using the token to sign the cookies, like combining the two and SHA-1ing them or something. And this is something that's sitting around for a long, long time. I mean, people will be using this same token years from now, possibly. So what's the possibility of just going to one conference, exporting your cookie, and starting to crack it, and maybe in a year's time, you'll have cracked it. What are they using to actually encrypt it? Whatever's in the cookie.
Yeah, okay, so if I understand correctly, the question is how can we prevent from this secret token mistake from happening even years from now?
No, but it's a slightly different thing because you're getting the secret token by going to GitHub. Yes. There's a secret token.
Or by connecting to the server. Well, you get at least a signature.
You get the signature. So as there's no secret in the signature, the token is the secret. But if you want to get the token, and they're doing no session management, then the signature must be made up entirely of the token and the cookie, and you sign the cookie with the token, and that gives you your signature. You're producing, like, the token and the cookie together are hashed, maybe, gives you a signature. And then you've got years, because there's conferences every year using the same software, you've got years to try and brute force back to the token from the cookie.
Okay, well, what you can brute force is not the token but the signature.
The signature, sorry, yes.
Yeah.
But the cookie gives you some of the information that you need.
I can show you one thing, which will work hopefully now. Okay, what we basically have here, I should. One way of testing if the secret token is indeed used, or if you can regenerate the signature by brute forcing, is comparing the signature, which is part of the original cookie, with a signature that you create yourself. And this is one test that does work here, but unfortunately the whole demo didn't work anymore. But what we did here is regenerating the signature, and I put that back in the cookie, and I tried to send the cookie to the server, which is one thing, but you can also just display the signature that you created yourself, and then if you did not alter the cookie, compare it with the original signature, which is what this part here below does. And if this gives back the value true, well, you already have the token, which is the string starting with 530. This is literally just copied from the GitHub file. But you can check this way if it is indeed used by the server. You get it from GitHub, and then you're testing it. We did a lot of problems with setting up our own local system, and then eventually doing a proof of concept against the server. But this is even a more easy way. Regenerate the signature and see if it compares to the first one. Does that answer your question? Maybe.
I suspect it does, yes.
Okay. Anyone else? No. Okay. Then thanks again, and have a good SIGINT.